Hello, hi, this is Rani Ahmed with you, and this is lesson 7 in Haskell, a programming language. And in this lesson, I'm going to talk about more about types, okay? And we're going to concentrate on the number class or type class. Now, let's go with the GSCI a little bit. GSCI, okay? Now, if we want to humanly calculate numbers, okay, we just don't think about it. Just like if it were like 1 plus 1.3, okay, you don't care, you just sum them up, multiply up, whatever you have to do with the calculation, you'll do it, and you won't care about the type of the number. Okay, however, with the computers it's a different case. When you want to calculate, okay, both sides of the calculation operation, okay, whether it's a plus, okay, or minus, okay, or whatever, it will have to be the same type. So what Haskell does is it unifies the types of both sides. Okay, so it puts them in a class called num type class. Okay, and a type class means the word type class means it's a sum of many different types, okay, in one set. Okay, so and as we know, numbers can be int, okay, and we saw that in a previous lesson, integer, and we got double, and also float. Good. Now the difference is, now we're going here more deeper with the types. The difference is that int means, like, if you have a CPU as 32-bit CPU, okay, 32-bit CPU, the maximum number, or the infinity for this CPU will be 2 to the power 32. Okay, I know it's illogical to say infinity about this, but you know the computer is limited. Okay, but it's what's supposed to be infinity. Okay, this is the biggest a number that can reach as an integer number. Okay. Now the minimal one, okay, the minimum is 1 minus the 2 power 32. The power, if you don't know, means that the repetition of multiplication. So I'm repeating the multiplication of 32 times. Okay, that's because of the number of bits of the CPU. Now, if it were like a 64-bit, similarly, okay, by changing the numbers, so it will be 64 here. Okay, so this is correct also. I'm saying that it's the minimal negative number, or the biggest absolute number in the negative side of the CPU, okay, negative numeration side, okay, will be 2 to the power 64 minus 1. Okay, remove 1 from 2 to the power 64. Okay, but it will be a negative number, of course. Good. If it were 128, just change it to 128. That's up to you. Okay, it depends on your CPU. Now, now what's the difference between int and integer? Now, integer, the complete word here, will give you no limit to the biggest number. See, if I use the int here, it will be using the CPU itself with its own limits. Okay, but the int versus integer, the integer is less efficient than the int. Okay, and it's slower, but gives you a bigger vast number. Okay, now double, okay, versus float, both are decimal numbers, but float is less efficient, less precise. Okay, so what Haskell does is it changes all the numbers when it calculates to double. Okay, so if I say like 4 over 3, okay, it will give you 1.33333. Now and as a proof that there's a problem with the calculation if both are different types, let's say I have a list, let x, okay, equals 1, 2, 3, okay, 3 numbers. Okay, so the length of x will be 3, of course. This is a new function you're now learning. So if I want to say 4 over the length of x, okay, there's a problem. It should give me 1.3 at least. Why? Because if we get the type of length, it will be what? It will be a list of anything. This A means anything, okay, represents anything, okay, and it should give and you input a list, so it gives you what? An int, okay, and the 4 here goes into the polymorphic state, okay, which you consider it as an integer for yourself, but Haskell, because it doesn't know what it has to do with it, so it puts it by default as a double. Okay, so it changes it to a double. And polymorph, morph means a shape, polymorph a number of shapes, so it will have a number of shapes. So the 4 can be an integer and can be double. Okay, you can take them both at the same time. There's no problem with that. So but with Haskell it will be a different case. Okay, so the solution for this is that there's another function will fix this situation called from integral. Okay, okay, there are so many other functions, okay, that comes like here, see, so run and it will give me that number. Cool. Now how do I get the integer division, the Euclidean division? The Euclidean division, just as by definition for those who don't know what I'm talking about, okay, you know it but you don't know maybe its name, is if I say x over y, okay, equals some divisor d or some factor here f multiplied by y plus some remainder. Okay, remainder can be 0, of course. So if I say, for example, 5 over 3, it is equal to 1 times 3 plus 2. Cool. So to fix this, we get a new function named div, and there's another function called mod. Now div gives me the division result, so div 5 and 3 will give you 1, and the remainder will be using the modulus mod. Okay, now mod is in C. Who know C is mod is equivalent to, this is not code, just for you to know, this is the percent here. Okay, now if I want to have it like in the calculation fashion where the operator is usually in the middle, okay, like the plus, you say 3 plus 2 or 6, whatever. So this plus is an infix operator. So if you want to put it as an infix operator, you just do it like this. 5, you know the tilde key on the keyboard, okay, this is the backtick, okay, they are on the same key, okay, one of them is on the shift, with the shift. So backtick and div or mod, whichever you want, 3, and this is the mod. You can put it like this, and we can also put the result as a tuple using a function named divMod. So divMod 5 and 3 will give me 1 and 2. Okay, so the div between us, this is between us, this is not in the code. Okay, I'm just defining things. So div will be fst of divMod 5 and 3, and a mod, okay, will be snd of divMod 5 and 3. Cool. So just by definition, this is the one. The first one is this one. This is the div, and this number 2 is represented by this function. Okay. So this is the mod, and you can still also use divMod like this as an infix operator. Okay. Now, what's the purpose for those who don't know, or how can I benefit from the remainder? Now, you know the time, the clock from somewhere in time. Okay, if you calculate the number of seconds since that time, okay, it always increases. So 1, 2, 3, 4, you know, like this. So the time always increases, and it's so fast. Now the computer can grab at some instance this number, okay, any number that it can catch. So it will be sorta random. So if you use the mod, okay, and for example, if you say any number time t mod, for example 6, or let's say 5, okay, so it will give you any number from 0 till 4. Okay, so this way you can choose between number a set of 5 people. Okay, you represent each one from 0 till 4. Okay, so this way you can have a random number. Cool. So that's all. Share the file, tell the people, subscribe, etc., etc., etc. Okay, there's a, you know, it's a good Haskell tutorial. Okay, and I hope you enjoyed it. Thanks for watching.